Hello, this is Mr. Gilmore with the 4.4 Part 2 Parallel Application Problems lesson. Well, in the 4.4 Part 1 lesson, we've taken a look at how these parallel tests and parallel consequences can work their way into proofs. Now, today, we're going to look at taking a look at generic application problems of how we can also use these tests and consequences. Let's take a look at our first example, an angle hunt. In certain angle hunt sections, you're going to be able to use the assumption that lines that appear parallel are. So in other words, that if I come across this diagram that we say have in this example below, the lines that I'm observing appear to be parallel to each other, which means I may assume they are. I can't assume that outside of examples such as angle hunting, such as this one. Well, what does this angle hunt actually involve? What it involves in is using our parallel consequences. Why are the consequences going to be used? Because we're given lines parallel. Now note that in our diagram we have several angles labeled as far as numbers, but that we're also given an angle measure. We're going to use that angle measure then to find the missing angle measures in this diagram. And we can actually find missing angle measures in many different ways. We can use past relationships such as linear pairs and vertical angles, but we'll also use new relationships such as alternate interior angles, corresponding angles. Let's jump into this angle hunt. In an angle hunt, you may not find all the angles in order, right? Doesn't necessarily mean we're going to find angle 1 first and then angle 5 last. We can actually find these angles in any order according to the angle relationship that we can actually establish. Let's first take a look at angle 1 and angle 2. They are actually the closest relationship to that angle 60 which is given. Immediately, I recognize that angle 1 and angle 60 form vertical angles, which means I can actually figure out the measure of angle 1 right off the bat. It is 60 degrees. We know that all vertical angles are equal. If I take a look at angle 2 here, angle 2 actually is a linear pair with that angle 60, which means I know that angle 2 and 60 must sum to 180 because all linear pairs are supplementary. Well, if the 60-degree angle there is already in place, then angle 2 must then be 180 minus 60, or in other words, 120 degrees. Now let's actually use our angle 1 and angle 2 then to help us prove or find the measures of angles 3, 4, and 5. If I take a look at angle 3 is actually directly related to the 60-degree angle. It is an alternate interior angle pair, which means if the lines are parallel, alternate interior angles are equal, which means I can then justify that angle 3 is also 60 degrees. I look at the relationship now with actually angle 2 and angle 5. Take a look at angle 2 and angle 5. If the lines are parallel, angle 2 and angle 5 would then be an equal pair of corresponding angles. And since angle 2 is 120, angle 5 is also 120. And now I can actually look at angle 4 and angle 5. Angle 4 and angle 5 are also directly related to each other. Those are a pair of alternate exterior angles. And because we have a pair of alternate exterior and the lines are parallel, those angles would be equal. So I could then justify that I know the measure of angle 4 is equal to the measure of angle 5, which is also 120 degrees. So on this worksheet, you're actually going to see that you're going to do several examples of angle hunting with the assumption that yes, lines that appear parallel are parallel. Let's take a look at another example. Let's do another angle hunt. In this diagram, we've already denoted that there we have a parallel pair of segments. And we're also given that we know some segments in the diagram are equal in measure, that AB is equal to BC. We're going to use what we know in this diagram to find the measures of angle 1, 2, and 3. And again, we may not go in order. I actually will more than likely go in order just a little bit. I actually will find the measure of angle 1 first. The measure of angle 1 first is directly related to one of the given angle measures in our diagram. It's related to the measure of the 45-degree angle. And here's why. These two angles here, angle 1 and angle 45, we can prove to be equal because with the set of segments here being parallel, then AC is a transversal. That's a pair of corresponding angles then. And all corresponding angles, if you cut through parallels, are in fact equal. So we know the measure of angle 1 is in fact 45 degrees. Now we are given that the entire triangle is isosceles, that AB is equal to BC. So we know this entire length here are equal. What does that mean for us? That means we know the base angles to be equal since it's isosceles. We'll take a look. Angle 2 and our angle 45 degrees are the two base angles, which means if they have to be equal, angle 2 also has to be 45 degrees. Now on to our third angle here, measure of angle 3. If we take a look, angle 3 is corresponding, see this? It's corresponding to our right angle, which means if those two angles are corresponding and the lines are parallel, those corresponding angles have to be equal, which then means angle 3 must be a 90-degree angle, because that would have to be a right angle as well. Let's take a look at then another type of example that we can use our parallel consequences to actually help us answer these. Actually, in this case, it would be a parallel test. See, the question in this diagram below asks this: do the lines M and N intersect? Well, if they do, on what side of the transversal will they intersect on? Will they intersect on the left or intersect on the right? Here's kind of a little story I want to tell you. Imagine that we have two lines, okay? And we cut through those lines in such a way that these two consecutive interior angles are both right, okay? If they're both right angles, then we could say, yeah, the two lines are parallel. But what if, instead of me calling one of those a right angle, what if I called one of them an 89-degree angle? What would then happen? Well, what happens then is this line on top is actually slanted in just a smidge, which means over time, what would happen is that line would eventually intersect the bottom line, right? They'd intersect on the left hand or on the right hand side of the transversal. So, in other words, what I'm introducing is in this case is we're looking at the sum of our consecutive interior angles. If the sum of the consecutive interior angles is less than 180 degrees, then it will intersect on that side of the transversal. So let's take a look at these two angles. We have 66 degrees and 112 degrees. Let's add those two together. What do we get? We get a sum of 178 degrees, right? 66 plus 112, that's a sum of 178 degrees, which means that is less than 180 degrees. So will M and N intersect? Yes, of course it will, because in order for the lines to be parallel, those two angles will have to be supplementary. Well, they're not supplementary. And because they're not supplementary, that means the lines will have to intersect. But on which side? It will always intersect on the side in which the sum of the consecutive interior angles is less than 180. Well, since that is on this current side, that means N and M will in fact intersect on the right side. So we can answer this question, right, this two-part question. Will they meet? Yes, they will meet. And on what side? The right side. And you're going to see several examples like that on your worksheet as well. To finish off, let's take a look at this polygon that we have in front of us. We are given some angle measures inside of this polygon and asked, are there any parallel sides? And then why or why not? Well, if I take a look at the angle relationship that's going on between the pairs of angles that are given, A, B, C, and D are actually, they can be transversals intersecting each other. In other words, there's a relationship, yes, between these two angles. Those two angles are consecutive interior angles. And if consecutive interior angles are supplementary, then the sides or then the lines that we know are being cut would have to be parallel. So in this case, if 72 and 108, which they in fact are supplementary, add up to 180 degrees, that means A is the transversal cutting through B and D. So I could then justify that B and D, those opposite sides, are in fact parallel. And this would be actually by the CIAT, the consecutive interior angles test, that if I have a pair of if I have a pair of supplementary consecutive interior angles, then the lines would have to be parallel. But at the same time, take a look at these other pair of angles. Those are also consecutive interior angles, but with a different transversal. B would then be the transversal. It's cutting through A and C. So at the same time, I could also call A and C parallel because those two pair of angles are also supplementary. And so again, by the CIAT, I would know that I have parallel sides as well. And you're going to see a couple examples like this on the worksheet. So please be sure to hop over and look at the 4.4 Part 2 worksheet. If you have any questions on that, please do not hesitate to email me. With that, be good and do good.